Welcome to the Chapter 5, Section 4, and Section 5 podcast. And now we're going to get into projectile motion now that we've talked about vectors. So, first two things we're going to look at here is the components of a vector, and talk about the horizontal component, and it's going to look just like a ball rolling along a level surface. And we're going to look at a vertical component, which is just going to look like something like a free-falling object, and we'll demonstrate that to you in this section. So let's define a projectile. A projectile is any object that moves through air or space, and it's acted only by gravity and air resistance, but we're going to talk without air resistance now. And if you see this guy coming out of the cannon, he's a projectile. He's been shot out, and once he leaves the cannon, there's no other force on him except gravity pulling down in the air resistance that he's pushing through. Some other examples: cannonball shot from a cannon, a stone thrown into the air, a ball rolling off the edge of a table, spacecraft circling the Earth, believe it or not, and I'll explain that. If you throw a ball across a room, that's now a projectile. These are all examples of projectiles. So, the projectiles near Earth are going to follow a curved path, and this curved path seem pretty complicated when you first look at it. This is a great photo of a curved path, and we're going to really break it down so it's very, very simple for you. And we're going to break it down into the two components, horizontal and vertical. And if you remember from 5-3, we said that the two components are separate from each other. They don't depend on each other. So if you roll a ball along a horizontal surface, the velocity is going to be constant. And the reason why the velocity is constant is because there's no other force acting on it other than gravity. We're just going to assume there's no friction. Now let's drop the ball, and what happens to it? Each second, the distance it covers becomes greater and greater each second. And this is that 5, 20, 45, 80. So we understand those two things. Now, this is what you have to remember, is that the two components are completely independent of each other. The horizontal component does not depend on the vertical component. They are independent of the other. And if you look at their combined effects, you're going to end up with that curved path that you see. And here's that curved path going down like that. Whoops, sorry. So let's look at this. If we look at we'll look at it again in chapter 5, but section 5. But if you look, the motion of the cannonball in the horizontal direction is the same as if it didn't have gravity, and in the vertical direction, you'll see it drops the same amount in the vertical direction as if it was only had gravity acting on it. So describe the components of projectile motion. The horizontal component is just like the horizontal motion of a ball moving along a level surface, and the vertical component of a projectile is like the motion for a freely falling object. 5-5. The downward motion of a horizontally launched projectile is the same as that of free fall. So let's look at a horizontally projected projectile here. And what we've done is they've used a strobe light to look at the ball as it just drops straight down, and a ball that's also been pushed out a little bit. And if you look, with each successive photograph, you'll see that the balls are actually in the same spot vertically. The ball's horizontal component also remains the same. If you look, the distance between there and there and there and there and there and there, it's all the same. So the horizontal component is constant. So the only acceleration on the ball is downward, and we can see it's getting each successive photograph, it's covering a larger and larger distance. So both the balls are going to fall the same vertical distance in the same time. They will hit the ground at the same time. And this tells us that the vertical distance falling has nothing to do with the horizontal component. The only difference between the red ball and the yellow ball is that the yellow ball was pushed a little bit horizontally, but they're both going to hit the ground at the same time. And they move. The ball here is moving the same horizontal distance because there's no component acting on it, so it's not accelerating in the horizontal direction. It's moving the same distance horizontally every time. So we call this path that's traced is called a parabola. This path is a parabola. And if we don't have really much air resistance, so we can actually neglect the air resistance. Now here's a little activity. If you take two coins and you put one right on the edge of the table, and you take a second coin and you flick it across the table so it strikes the coin that's overhanging, both of them should hit the floor at the same time. And on top of that, the speed of the sliding coin should make no difference at all. So at the instant a horizontally pointed cannon is fired, a cannonball held at the cannon side is released and drops to the ground. Which one strikes the ground first, the one fired or the one dropped? They fall at the same distance, same vertical distance, with the same acceleration, so therefore they're going to strike the ground at the same time. There's no difference. They should hit the ground at the same time, just like we saw the two coins will hit the ground at the same time. So describe the downward motion of a horizontally launched projectile. The downward motion of a horizontally launched projectile is the same as that of free fall.